data and we looked at what's called the clean air delivery rate. The clean air delivery rate is kind of an offset of the outside air requirements for a building. So to put some numbers to this, if you had 75 CFM, that's cubic feet per minute of airflow that you need for a building, for an energy efficient house, and we find out that the biowall can provide 30 cubic feet per minute of airflow in clean air, then your new outside air requirement would be 45 cubic feet per minute. So the idea is that we want to characterize this filter in such a way that we can reduce outside air requirements, and by reducing those outside air requirements, we can reduce our energy consumption. Well, so far, based on the graph that I showed you with our indoor air quality improvements, we showed that we can definitely improve indoor air quality with the biowall, and we have statistical significance behind that claim. But if you plug that into an energy model, the clean air delivery rate is closer to 1 CFM, which isn't a whole lot right now. A lot of this, we believe, the reason behind it is that we didn't have any activated carbon or anything like that, and so that activated carbon would help improve the filtration capacity of the wall. A similar study, going back to that energy efficiency study done by Syracuse University, they achieved clean air delivery rates closer to 1,200 CFM with the use of activated carbon. So just for the purposes of modeling, we took a target of where we think the biowall can go of 30 CFM as a clean air delivery rate, and we ran with that for our energy modeling. So what were the results? What we did is we looked at different scenarios. So, what's the location, what's the geographic location, and what are some of the operating conditions? The 4 operating conditions you see on the x-axis, which are a combination of whether you have a biowall, whether you have energy recovery ventilator, whether you have both, or whether you have neither. And as you might expect, they're both energy efficient technologies, so the best combination is to have both, and the worst combination is to have neither. But there's some interesting things that go on there when choosing between the two, and I won't go into all of them just for time's sake. But basically, you can look at this graph and say that a biowall will reduce HVAC energy consumption in an energy efficient residence by about 10 to 30%. And that's kind of like the big takeaway message for that graph. So where do we go from here? We've shown an improvement in indoor air quality and a reduction in energy, which is kind of what we set out to do. And also looked at the improvement of plant life and plant health and figuring out ways to optimize that. So kind of going along with that idea of optimization, we want to improve the design. We want to include activated carbon. I kind of mentioned that already, because that's a known filter and can improve the filtration capacity. We also want to make our our irrigation system a little bit more durable and make it out of PVC. Right now we've got these press fit pipes that could be improved to some extent. We also want to filter the water going to the plants. We've run into a little bit of problems with the water directly from the building and the West Lafayette water supply. I guess it had chemical compounds in it that were not healthy for the plants. So we need to filter that in the future so that we can provide them better water for the plant growth. And then just further optimizing plant species and growing media, figuring out what's the best way to grow these plants vertically, and also what plant species. Plant species, one of the things that I didn't have a chance to talk about in the slideshow was we achieved, so typically we had more foliage-based plants, but during the scope of my work, we also achieved flowering in the plants, which is, moving along in the progression of having better plant health. Even farther beyond that, we might be able to produce crops or something, or grow mint or something like that, and pick other plants that have more functional purposes, like an aloe or something like that. So setting goals for the next couple months and even beyond my work with the next couple of years, we're going to be moving to the National Sustainable Design Expo. So that goes back to the team that I was talking about at the beginning of the presentation. We're going to Washington, D.C. at the end of April, and we're going to be presenting this and hopefully qualifying for the Phase 2 funding of the grant. There's going to be a number of presentations and papers and things like that, similar to what's going on here today. And then in the next couple of years, we're hoping to reevaluate the design and optimize it, reevaluate it in the lab setting, then move it towards a field testing and actually evaluate its impact on energy consumption outside of the lab, which would be a big step forward in our claims about energy reduction. And then, once we have that, the next step is commercialization and starting to try to sell this product. And then, potentially, long-term goal is when we have someone looking at an energy efficient house, they might have a building contractor that can give you a biowall as an option on that energy efficient house that you're building, kind of an add-in to what you hope to put into it. And that actually ties into what everyone's doing tomorrow with the Whirlpool house. So the place where we plan to do our field testing is in the Whirlpool Renew house, which I think there's a tour for tomorrow. So I'm sure that'll probably be talked about. And that's what's going on in the bottom left-hand corner is a SketchUp drawing of that house. And you can kind of see the bio wall. It's towards the middle of it. It's a little hard to see, but the bio wall is going to be featured in that house as well. And then I talked about this a little bit, we're moving towards commercialization, pitching into building contractors, and ultimately we also want the test methodology that we're developing here is kind of an emerging field. ASHRAE, USGBC, they're all starting to look at, how do we filter these gaseous contaminants, and how do we actually measure the amounts, and how do we do this accurately? Excuse me. So we've got just two quotes up there from ASHRAE and USGBC. They provided letters of support when we were writing to the EPA about our project and how we believe we can move on to the next phase. And it just talks about performance indoor air quality standards, which basically means looking at the amount of indoor air quality and looking at what is the current state of it, and then adjusting ventilation rates and reduction rates based on what our current status of indoor air quality is, whereas normally we just specify a current ventilation rate based on other standards and don't really monitor what's going on exactly in that room. And I think that's about it. So I wanted to leave plenty of time for questions. I want this to be a little bit of a dialogue where, if you have any ideas about this or would like to ask anything, go ahead.
I think this is fantastic because I've always wanted to go this route with certain things. Is there any research being done on taking this more to the next level, which is commercial, so that there can be actually commercial bio walls? I know there's bio walls for commercial applications already, but I don't know how much in the way of research is out there in figuring out the energy saved by using
Sure.
bio walls.
Yeah, so as far as like academic articles go, that Wayne study by Syracuse University that I keep referencing, that's the primary one for commercial energy reduction. And it's Syracuse University, Wayne Zhang 2011 or something like that, but I can give you the reference. There are living walls, as you mentioned before, but those are more aesthetically based, whereas ours is both, we're trying to do both aesthetics and function by filtering the air. There's also Alan Darlington, who I mentioned in the literature review. He has a company that will install functional biowalls in the commercial setting. And he's done a little bit of research on the energy effects and the health impacts of functional biowalls. But, for what we're doing, we're mostly focusing on the residential sector.
Because I only inquire because I see that, especially for hospitals, that could be a key element that you're helping heal the patients at the same time, make sure that you're not introducing any new problems that complicate things and make them stay in the hospital longer.
Absolutely. And there's something to be said for nursing, I guess for lack of a better word as well. Like if someone's in a hospital and they have something to take care of, like they could help take care of the biowall, that might help improve their health and, other psychological benefits like that. Go ahead.
Is there research on specific plants that are the most useful? And And then also, you talked about at the beginning, looking for how there's like benign VOCs and non-benign VOCs. When you're testing an indoor air quality, how do you tell the difference between those two?
Okay. So can you repeat the first question? I'll start with that one.
What are the most helpful plants for
Sure.
that kind of?
So, answer to that question is Bill Wolverton, the NASA research scientist. He actually came out with a book that I'd recommend to anyone who's interested in this. It's very easy to understand, and it'll show you each plant, and it's called like How to Grow Fresh Air, 50 Ways of Improving Your Indoor Air Quality or something like that. But it shows 50 different plants and it rates them on how much water they use, what their indoor air quality cleaning potential is, and it actually has like a scale of 1 to 10. It's based off of his research from NASA. And then also how much light they need, whether they're prone to pests or anything like that. So he did a bunch of work, but I think there's been hundreds of plants that have been considered. I was reading a literature review article the other day, and this came out about a year ago, and it said, hundreds of plants have been considered, everything from foliage plants